If you're analyzing your survival time data using Cox regression in Stata, and you have a numerical variable, and you don't know whether you analyze this variable the way it is, or you should consider categorizing, and if so, using which cutoffs, this video is going to take you through the process of determining the most appropriate functional form of a numeric variable for your analysis. In our previous episode, we checked for the assumption, and if you want to know the detailed procedures of choosing variables to include in your multivariable analysis, consider watching our video under binary logistic regression, where we choose variables to include in multivariable analysis. The principles are the same even for the Cox regression model. Here is our hypothetical survival time data that we are going to use for this demonstration, where we have ID, where we have the event date, whether it happened or not, and then time to event. Then we have three independent variables. We have this independent variable called age, which is continuous, and we don't know whether should we analyze this variable the way it is, or should we consider categorizing it. We have to consider using the most appropriate functional form of this continuous variable in our model. Why should we even be bothered about checking the functional form of a covariate or a numerical independent variable in Cox regression? First, Cox regression assumes that the log of hazard is a linear function of covariates. That is basically from the way the formula for the Cox model is written out, as we can see here, or also written as the log of hazard at time t relative to the baseline as a linear function of covariates. For continuous variables, this may not be strictly linear, so we must check if they should remain numeric or be categorized. But if we are to categorize, which criteria should we follow in the categorization? So what we do, we obtain the cutoffs for categorizing using quantities called Martingale residuals. So we run a model having the uncategorized version of that variable, and also run a model having the categorized version of that variable. Then we compare both using model fit statistics, the ICAC and the Bayesian information criteria. We see which of the two models is better. So that's what we are going to do right now in Stata. The first step is to declare our data to be survival time data in Stata, which we do through statistics, survival analysis, setup and utilities, then declare data to be survival time data. In this dialog box, we specify what our time variable is, and here our time to event is the variable time, and then our variable showing whether the event date has happened or not is our variable called event here, and within that variable, what is the coding for whether the event has happened, and that is a 1. Then we click OK. The output will give you here the details of the survival time data settings, as you can see. Also note that we have about 4 variables that have been included in your variables window that are as a result of this declaration of our data being survival time data. Remember our aim when we browse our data. We have our independent variable called age that we don't know whether we should categorize it or consider it the way it is. So the first thing we shall do is to fit a null model without any variables within it. Simply go to statistics, go to survival analysis, regression models, and then Cox proportional hazards model. Then you tick this box of fit model without covariates and then click OK. So here we have estimates of a model without any independent variable of ours. So we use this model to predict the quantities of Martingale residuals, which we are going to plot against each of our covariate to see whether there are any departures from that linearity. To predict the Martingale residuals, simply go to statistics, go to cost estimation, and then under predictions, you're going to click on hazard ratios, survival functions, etc. And then this dialog box opens with the number of post estimations or predictions that we can make. So we are interested in the Martingale residuals here. Then we click on, we give it a name. Maybe you can just give it Martingale. And then I click OK. When you check our variables box, we have Martingale residuals which have been predicted. If I browse here, you can see that we have a new variable with values. So we plot Martingale residuals against that numeric variable, and we see the pattern. If there are any deviations from being linear, then at that point we consider categorizing it. So we shall go to graphics, then we go to two-way graph, and then we shall create a graph. We want to have a basic plot where our y is the Martingale residuals here obtained from the null model, and then our x variable, which is that numerical variable, we want to see whether at what point can we categorize it. Then accept. We are also going to add another plot of the lowest line. Go to create, and then under advanced plots you can add the lowest line here. Then y is still the Martingale residuals, and x is that numerical variable age. Accept, and then we can submit. Here is our graph, and we can see that it is not a perfect linear line. It goes down and then up again. So we can consider categorizing our numeric variable at maybe this point, because I can see maybe from here we have a negative deviation, then at this point we have the positive one. So I can consider categorizing my numeric value at maybe 52. Sometimes you may have a graph that looks like this. The biggest portion of the line is linear, but at the beginning here, that's where we have the violations. So that is the point where you could consider categorizing your variable and compare a model where you've categorized it at that point, or where you have the numeric variable. So for this demonstration, we are just going to categorize our data at approximately 52. So we are going to create a variable from this variable called age into a categorized age. So we shall say, we shall record this variable age here in two categories of from the minimum value up to 52. We shall give it a 1, and then 53 up to the maximum, we shall give it a 2, and then generate a new variable called age cat for age category. Enter. Then we shall have here our age category created, which we can also label. If I just go to, I click on that variable. Under value labels, I can just come here under 3 dots and I create a new label for age category. Then where 1 is below 53, add this, and then 2 is 53 and above. 53 and above. Then add this and click OK. Then I can close this window and assign the value labels of age cut. So you can now see that our data is now labeled. You can close this. So now we are going to run a model having age, when it is continuous, we store the estimates. Then we have to run a model having our age categories. We store the estimates and then compare them. So let's start by running a model having numeric age. So go to statistics, till survival analysis, then regression models, Cox proportional hazards model here. Then under the independent variables, we are going to put in, we are unchecking this box for fit model without covariates. Then we put in our variables. We have gender, we have treatment, and we have age. If you want to indicate that these two are categorical variables, you can just put I dot before the variable name to show that these are categorical variables, and Stata should treat it that way. Then we can click submit. So this is our model that has age as a continuous variable. We are now going to store the estimates from this model. Go to statistics, post estimation, and then manage estimation results. And then here you'll see store current estimates in memory, and then launch that. You're going to give it a name for that model you are storing. So we can just call it age numeric. Click OK, and estimates have been stored in memory. Then we are also going to run the model with the categorized age. So statistics, survival analysis, regression models, Cox. And this time round, instead of this age, we are putting in the age category here. And then we click OK. We are also going to store the estimates. We can even just use this command, and then we change the name here to age cat at 53. Then we enter. So we have stored estimates for two models, one with age category and one with age as numeric. So next we are going to compare the two models using model fit statistics. Go to statistics, post estimation, and then go to manage estimation results. Then ask for table of fit statistics. Select report model selection statistics for stored estimation results here, and then you put in your two models. The order doesn't matter, and then you can click submit. So here we have the ICAIC and Bayesian information criteria used for model selection, and we are interested in a value with the lowest AIC and BICs. So when we look at our model with the numeric age, it has 1576 for AIC, which is lower than the one for age category 53, and then even the BIC 1587, 1589, showing us that our model with a numeric age is better than our model with the categorical age. Here are some points that we need to note when we are checking the functional form of a covariate. First of all, let me bring back the two-way graph here. First of all, you have to try out creating several categories based on the behavior of your graph that you've plotted. For example, this one I've created at this point, but if I had a graph like the one I just showed you, I would try maybe to create three categories, maybe one from here up to this point, 0 to maybe 25, then 26 to about 49, and then 52, maybe up to the maximum. I would have like three categories and then compare them. But what is also important to note is that you may have a variable, a numeric variable, with known cutoffs or standard cutoff values. For example, you're dealing with random blood sugar measurements where we have known cutoffs that if someone has above this value, that is maybe considered pre-diabetic, or this is diabetic. So consider using those standard cutoffs where you have them and compare whether should you categorize or you should just treat that variable the way it is. And lastly, it is advisable to create between 2 to 3 categories. Avoid creating very many categories because you may end up with categories that have fewer participants, which will affect your model eventually. So that's how we can check for the functional form of covariates in Cox regression using Stata. If you found this video useful, consider liking and subscribing to the channel so that you don't miss out any of our episodes. So next we shall look at checking for overall model fit in Cox regression analysis. If you want to know how to test for confounding, interaction, choosing models, and checking for assumption of Cox, we have previous episodes. We have those under binary logistic regression, that is step 2 up to 4, where the principles are the same even for Cox model. Consider watching them. See you in the next episode.